Hello everyone. Welcome to the another session of Data series. We'll be starting the session in 5 minutes. Till then, let's get to know each other. We have put up a poll. Kindly answer the question. Thanks everyone for joining us today. We'll start the session in 2-3 minutes. Let's wait for everyone to join and settle in.
Hello there. How's everybody's afternoon going? That's great to hear. Okay, I hope everybody have your lunch. Thanks for joining in at this time, actually. It's lunchtime almost.
Good afternoon, Nithin.
Good afternoon.
Yeah, so we'll start with the session. So, hello everyone. Welcome to the another session of the data series. We will start in just 1 more minute. Till then, let's get to know each other. We have put up a poll. Please kindly answer all the questions, and we'll start the session in just few more seconds more. Yes. So, hi and welcome everyone to the another session in the data series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Diksha Dhaiya, part of data science team at Analytics Vidya. For those who have joined us for the first time, a brief introduction to the data session. The Data is a series of webinars conducted by Analytics Vidya and led by a top industry expert. It's a fun way to understand the concept of data science, data engineering, software engineering, and blockchain from the leading players in the industry. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is data wrangling using geospatial data in Python. Geospatial data is a world unto itself, having lots of format, lots of file types, lots of information, all within a single file. In this session, the speaker will discuss geospatial data, the representation of 3D view of the Earth on a 2D plane, ways to access various satellite format, available Python libraries for geospatial data, application Geopandas, and basics of the data plotting. So before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping item. We are recording the session and the recording will be live on our YouTube channel. The link you can find in the chat section. Please use question answer for asking any question you might have during the session, and we will do our best to answer them as the data progresses on towards the end. We will be sharing a feedback poll towards the end. You all are requested to kindly fill up the form before leaving the session. Now on to our speaker. On this session of the data, we have Nithin Srivatsav with us. Nithin is a passionate data scientist who loves solving problems. In last 4 years of experience, he has built multiple end-to-end pipelines for environmental intelligence in AdTech and digital healthcare spaces, and is currently working as senior data scientist at Ambi. You can connect with him on LinkedIn. The link is present in the chat window. We are also hosting this webinar live in our YouTube channel, and the channel link is present in the chat window. You can even follow up from there too. Thank you. Over to you, Nithin. The virtual stage is all yours.
Thank you. Thank you so much, Diksha. I hope I said that right. Okay. So let me just share my screen and let's dive right into this. Okay. I'm presuming you're able to see my screen. Just a second there. Okay, cool. Right. So, hey guys, welcome to today's data session, and we'll be working with geospatial data in Python. We'll look at various types of file formats, various types of plottings, and we'll see how to access satellite data, how is it stored, and a little bit of plotting on QGIS, and it's going to be loads of fun. So before we get started, I'm Nithin Srivatsav. I am a senior data scientist at Ambi. I have close to 4 years of experience in building multiple end-to-end pipelines, especially in the digital healthcare and AdTech spaces. And I own a couple of patents. There are some in the way as well. My team and I, we built India's first and the global pollen data, which is available on our website, Ambi. Hobbies include a little bit of motorcycling and reading books, especially self-help and productivity. Okay, enough intro about me. Let's dive into the presentation. So here is what you'll be getting to see in the presentation, the table of contents. First, we'll understand what geospatial data is, where is it used, how is it useful, and then we'll get our basics right. We'll understand what is a lat long, how is it represented, what are coordinate reference systems, how is a 3D view of the world presented as a 2D plane, and understanding some specific data formats. We'll look at an example of QGIS and how we can visualize that. And then we'll deep dive into Geopandas, understanding its data types, shape files, a little bit of basic plotting, and important functions that are of help. And finally, we'll conclude and we can get on with the QA session. Right, okay. So what is geospatial data? Any data that can be referenced to a point on globe is known as geospatial data. For example, we have COVID data, we have weather data, all your Uber rides, your Swiggy, Zomato orders, your Myntra, Flipkart orders, everything has a data point linked to it. So when you make an order on Flipkart, there is your home address, which is linked to a point. Now in Flipkart's backend servers, they store it in a way which can further be used to utilize and derive business intelligence. For example, which area took a lot of orders, or where did most of your orders go? Where did most incoming come from? And what were the products? Everything can be referenced to a point on map. And using that, we can derive business intelligence. Now, when I say business intelligence, a lot of applications. So say, for example, we have Uber's data. So Uber has collected all your rides of everybody in a locality, and they plot it on a map. Now we can understand which time of the hour has a lot of traffic so that I can add more cars there so that my order will increase. Similarly, there is weather data. Say you're planning a Goa trip and you want to know what's the weather there. So you go to Google and you check Goa's weather. Now, there backend, there's a location for Goa for which weather data is mapped, which is being displayed to you. So here are ways, here are the places where geospatial data is used. There are very numerous amounts of uses that geospatial data has. Say, for example, COVID-19 data set. Back then when there was restrictions and curfew, we could know where a lot of COVID cases were coming from. We can plot an entire heat map of where COVID cases were there. So these are some of the applications that geospatial data holds for us. So now let's look at the backend, or how geospatial data works in the backend. What's the entire funda about it? So you have your globe, and then that globe is divided into long latitudes. You have your equator, you have your Tropic of Cancer, Tropic of Capricorn, your North Pole, South Pole, and then you have longitudes. So this is what a lat-long mapping of our globe looks like. But now, what if I tell you the map that you see, the map that we have known from our childhood, the world map, is not exactly how it looks. It looks like this. The world looks like this. So the sketch you can see is what we see on the world map. But actually, if you take into relative distances into consideration, this is how the map looks like, the green part. It's stretched. But what we do is we use an accepted standard, that is coordinate reference system, and we show it in a concise way that is accepted universally. So the black sketch is what we see on the world map, but if you look at the relative sizes of how they look, the background green color is how our world actually looks like. So now that brings us to the map, which is lat and long. So everything to the right side of this is not east. This is west. The top portion is north, and the bottom portion is south. This is one way of representing it. Say 12,77 is 12 north and 77 east. So if we were to take an example of Bangalore, whose latitude and longitude is 12,77, what I would do is I would go here to 12 almost, and then I would go to 77 here, which almost comes down to here, which is approximate location. So this is how we map a lat long to the entire world map. So right side is positive and the left side is negative. The top side is positive again, and the bottom part is negative. Okay. Now let's move on to satellite data. So in this specific website, or in this specific slide, we'll understand what satellite data is about. Now we will be skipping all the Uber, Swiggy data sets, and we'll be looking at weather data, pollen data, anything that needs to be that deals with satellite data. Okay, so there are two types of satellites usually that which collect the data, which are geostationary and orbital. Now, what geostationary does is it is fixed with reference to the globe. So as and when the globe moves, the satellite moves in the same way. So you can see here on the left-hand side, it is in the same position as the globe. So it is revolving with the globe. So for a person standing on Earth, he would see the satellite as motionless, but in actual, it is moving. And the second type of data sets are orbital data sets. Now, what this do is it orbits around the Earth in its own fashion, in its own orbit. Now you can see here. So what it does is, if this is the globe, it moves in circular motion around the globe in its own orbit, covering all parts of the globe and capturing data that's relevant to it. Now, a typical weather data or a satellite data that consumes information almost accounts to 100 TB of data. Now that's a very, very large chunk of data, even for us to process on the local systems. What these weather or satellite data providers do is they have very high resource rich computers, supercomputers even, and they process that data and they pack a lot of data, a lot of information into a single file. Now that file will drop down to say 2 MB, 3 MB file, but it contains a lot of information and it's packed so closely together in a specific format, because of which the file is so less. Else it would have taken 100 TB of data, that which is really huge. So there are some common formats that satellites use, which is HDF files, NC files, there is GRIP, and there's also GeoTIFF files. We'll be exploring HDF in subsequent slides. And now we'll just visualize a QGIS pollen data. Now before that, let's first, let me open that just a second. Let me just share the proper screen. Okay. So I presume you're able to see the notebook. Okay, so first let's see what type of file we are looking at and how that can be visualized in QGIS. So let's just import our libraries. And let's also import a Geopandas library, which you'll understand why we are doing that in a second. And matplotlib library for plotting. Now I am assuming you already have enough experience with pandas, data frames, and plotting, so that this isn't very new to you. Let's just read the data set, which is pollen.data.csv. So let's just look at the head of the data. So it has latitude, longitude. So that's geospatial data. We have a postcode. We have created a timestamp. There is grass pollen, there's tree pollen, and there's wheat pollen. Okay. Now let's just create a Geopandas data frame. Now stay with me here. I'll be explaining that in subsequent slides. So let's create a geodata frame, which uses Geopandas library and creates a geodata frame. Now, this might be new to you, but you'll understand in a second how this is happening. We have EPSG 4326. So this CRS, which stands for Coordinate Reference System, is the generally accepted standard globally for a view of a map. So in the previous slide, when I told there is a general standard that's accepted, that's EPSG 4326. It's a name for the coordinate reference system. Okay, and next we have geometry. PD dot. We have a longitude and we have a latitude. So now a Geopandas data frame has been created. Let's just visualize how that looks like. It's pretty much a Pandas data frame itself, except there is one column called geometry. This is the last column. Now this is very important for a Geopandas library because this geometry column is what tells us that the data is linked to a point on map. Okay, so I'll just zoom in just in case you're unable to see the screen. I think this should be good. Okay, now let's just plot it. gpd.plot. Let's plot the column tree pollen because that has numbers in it. And let's add a figure size just so we can visualize it properly. 10. Sorry, that should be GDF. Okay, so this is the pollen data which spans USA and Canada. So you see, geospatial data has a lat long to it, identified by a column called geometry, and that is being plotted here. Now this doesn't make sense, right? I mean, I cannot see the boundaries, I cannot see what the color map explains. So let's add a few parameters to that as well. So to add a background map to this, we'll have to pull in another data frame. So this is already available in Geopandas. Read file similar to read CSV in Pandas. And we have a data set. Datasets, we get path from it. And it's called natural earth loess. Now let's see what this data frame actually contains. So it contains a continent here and the name for it, and again the geometry, which is really important. Now you can see there's something different here. There's a polygon, there's a multi-polygon, but our data frame had point. We'll be understanding that in a separate notebook which dives deep into what Geopandas is all about. Okay, now once this is done, let's just filter it for our continent. So continent is equal to North America. Okay. Now let's just plot it to see how it looks like. Okay, so this is map of the US, Canada. So now let's add this as the background for our image so that we can see where pollen counts actually are. So let's just create a subplot. With figure size as say 20,16 just to visualize it properly. Now let's plot the world map. Refer it to AX. And let's also plot our geodata frame. Let's add legend equal to true so that we understand what the scale is about. And a figure size again. And refer it to AX. So now once we do that, okay, did we not? Right, here we go. Rookie mistake. Right, now you can see the legend here. And you have Poland data that's mapped on the North America map. So now we get an idea of, okay, it's high, the counts are high here, and it's pretty much low everywhere else. So this is the data that we are trying to look at.
I'm sorry to interrupt you, but I think your screen is not visible properly. I think it's hanged.
Is it? Let me just reshare. Just a second. Thanks for pointing that out. Desktop one. Okay, is it visible now?
Yes, yeah.
Okay. All right. Okay, I was sharing the other screen. Okay, sorry. Okay, let me just rerun through the notebook again very quickly. Okay, we imported a pandas, we read the data set, and we created a Geopandas data frame, and then we have the head. Then we just plotted it on a map without anything, and then we came forward. There is we read the natural earth low-res, which is a Geopandas dataset, inbuilt dataset. So this is what I was mentioning. The geometry is that's what is most important for Geopandas data frame to understand what it is. So you have multi-polygon here, and you have point here now, which will be deep diving again, as I mentioned. And then we took the continent of North America. So this is what it looks like. And then we mapped those both to plot it like this. So we have Poland data on top of the US continent. So this is what we did in the notebook. Please excuse me for sharing the wrong screen. And let me just share now the QGIS tool, which offers us a really good way to interact. Now I'm sure the screen is visible. I think it is. So whatever we saw on that map is here in QGIS tool. I will not be deep diving into how QGIS works because it's a little complex and will require a session on its own. So here we have, so we saw it's high here. So you can play around with QGIS like this. So there's a tool that exists that is specifically built for visualization and exploring geospatial data. So you have data here, Canada, and you have here. So if I can zoom in, I can see the individual points, the points that were present in the map. Okay, cool. Let me reshare again with a new screen. All right, so we saw what the data set was about and what QGIS is. And now let's move on to Geopandas. So Geopandas is the go-to library for geospatial data. There are a lot of geometric objects in that through which we can play around. and there is points, there's lines, and there are polygons and shapely objects as well. Okay, any questions so far? Okay, none. Cool. Okay, so now let's deep dive into Geopandas library. Now, actually, before that, just realizing, so there are a lot of satellite data formats, right? So let's just look at one example of a HDF file on how that works. And let's just explore the library and just read a data frame and see what exactly our HDF files are about. Sharing screen is a headache. All right. So hopefully this time I am sharing the actual screen. Okay, cool. So let's just import pandas as PD. Now, in order to access the HDF file, we'll need a specific library, which is called PyHDF, which can be installed using pip install PyHDF or conda install -c conda forge PyHDF. So let's just import that. PyHDF.sd import ST and STC. So you needn't worry about all the terminologies. It's okay to understand that these are the libraries that are required to read specific formats. Okay. ST and we have dot. We have a file, which is a file from NASA, which is the MODIS file, which contains water vapor data in it. So we pass STC dot read. So now we have the file contents and we can see the parameters that are present inside that as file.data. If you can see, this HDF file contains latitude, longitude, again important for geospatial data, the scan start time, a couple of sensor values, cloud mask, water vapor, near infrared, and stuff. This is our focus here for now. So right, let's select these columns, the columns that we need. So that we need the latitude, we need the longitude, and we need the water vapor data. So let's select that. I'll just type in quickly. So we need water vapor. We select it from the file.select. Yeah, water vapor infrared. We have the latitudes, which are in the latitude column. So again, so these are the data dictionary. These are the columns that are present in the HDF file. And we'll be taking these from the HDL file and creating a pandas data frame there. So there's latitude, which is important to us, and longitude. So let's take that. There's latitude. And we have long, which is file.select. Okay. Now here is where things get interesting. Let's just first take the data from the selected fields, and you'll understand where things get interesting. So now if I print this is an array. Now, if I just convert this into a data frame, you'll see how it is mapped to the entire world and the format of HD. So that's data frame, water. Now, if I see water data, So this is a x comma y grid, which contains only values at a specific place, but rest every of that is minus 999, meaning invalid value. Now, this explains us that the data that we got from the satellite is orbital one, because there's no data for the entire world. It's only there for a specific region. So what we do is, now let's just take the latitude and longitude as well. Let's just type it in here as latitude equal to long dot get, and let's create the data frames respectively. Okay, so now if we just visualize the lat long, so it's a map again. So what's happening in the backend in a HDF file is, say for example, so there's one layer. Now this contains all the latitudes and all the latitudes of the world, and then there is longitude file. So there are two files now: latitude, which contains all the latitudes of the world; longitude, which contains all the values of the world; and then we have water vapor data, which we took, that contains for all the individual mappings. Now, when we merge all these three together, all these three files merged together, is how HDF is stored in the backend. So it's not like your traditional lat, long, and then water vapor, but rather it's a 3D mapping of latitude, longitude, and the water vapor data. Okay, so now let's just merge them into the format that we want. It's a pretty long code, so that I'll just copy paste it here instead of wasting time typing. And we have a data frame. So this is how our data frame looks like. Okay, just a second, some variable data. Okay, here we go. Some variable changes here. Right, so now we have the entire data frame. Now that contains minus 999 values. So let's just remove the values that are not 999. So the water vapor not equal to minus 9999. Okay, so out of the entire 72,000 locations, only 52,000 locations had actual valid lat long value or water vapor value. And let's just save it to a CSV, water vapor dot CSV. So this is how we took a satellite data, took all the parameters that we need, and then converted into a data frame that's understandable to us. So this is an example of HDF. There are other libraries and other files that are, netcdf, there are grib files, there are geotiff files, and each has a Python library which we can use to take data and convert it into a format that we want. Okay, now let's move on to the Geopandas data frame and deep diving into what Geopandas is about. Let's create a new notebook. And that's Geopandas intro. Okay, sharing the screen again. Okay. Right. Sarang is asking, there's one HDF file, and what if we have data for multiple years? So you'll have to process the file individually. Now there are advanced methods on how you can do this in parallel. There are glue jobs in AWS where it runs through the entire HDF files and then converts it into a single data frame. So, but in order to process, you'll have to do it one file and one by one. Okay, I'll just answer some of the questions here. So I use Tableau. Can we use it for visualizations? Yes, we can. Again, I'm not really much well versed with Tableau, but there is an option to visualize QGIS. I mean, geospatial data in Tableau. And Abdul is asking, where can we get geospatial data set? Right. So geospatial data sets is anywhere. You can find it in Ambi and any weather data provider. So everything is there in Ambi actually. And there are some Kaggle open source data sets available for Uber data sets or Swiggy orders, Zomato orders. So anything that has latitude and longitude to it, that can be considered as geospatial data. Yes, I can recommend a textbook. I have a couple of links which I will be sharing at the end of this presentation. I will also add it to my GitHub profile that you can check in. All right, let's move into Geopandas intro. So what this session is being aimed at is not deep diving into geospatial data or getting into depth and messing with our minds, but rather an overview or a kind of an information for you, like, all right, there is geospatial data and there is geospatial data science. If I ever come across any sort of application, I can utilize this. And okay, these are the libraries that I need. So this is the sort of information that I'm trying to convey in this session. If you want, we can deep dive into geospatial data science in subsequent sessions, or even deep dive into QGIS, which is an excellent tool in creating raster files, in creating TIFF files, and more to do with satellite data and pure raw geospatial data. That's where QGIS is used. So let me know in chat and comments on if you want that session or not. Okay, let's just dive into now the Geopandas. So first, let's import our necessary libraries. Or, let me just copy paste, I think we're wasting too much time. We can discuss better things. Okay, right. So we imported pandas, which is a well-versed library. There's Geopandas, there's Shapely Geometry, and there's Matplotlib. Now, Geopandas is something that you just came in touch with. And Shapely, again, is kind of a base layer on top of which Geopandas works. So there is Shapely Geometry. So we'll understand what a point is, what a polygon is, what a line string is, and what a multi-polygon is. So these make up the backend of Geopandas and your filterings and functions that you can use. So we'll be exploring that one by one. So, in Pandas, there are two types of data types, right? One is the Pandas data frame, and the other one is Pandas series. So Pandas series make up the Pandas data frame. Similarly, in Geopandas, there is Geo data frame and Geo data series. So same convention, same working, just it's different. Works with Pandas, works with GeoFrame. So now let's explore what point is. So point is a single latitude and longitude that you can plot on a map. Now, if I execute the cell, it's a single point, 12,77. Now you cannot see where it's located because we haven't added the coordinate reference system or the map on top of which we can paste this. But so a point is a single latitude and longitude that you can identify on a map. Now line string is a collection of points that you can draw a line on in the map. Okay, so let's just create a line string which contains an array of values. So 0, 0, and then let's say we have 1, 0. Now, if I just plot this, you see it's a line from 0, 0 to 1, 0. Now, if we just do 1, 1, so you see how it moved. Now, if I do 0, 1, so you see how those three matched, right? So it's creating a line in the plane. Okay, next we have a polygon. So polygon is similar to a line string, but it completes a map or it completes an area. So if we just take a couple of coordinates, so these are the coordinates. And now if I create a polygon on top of it, and let's just display that. So you see it has completed a square. Now, what if we were to check how, the line string that we defined here as a polygon? So I would say polygon of L. So instead of these three lines, it has covered it. So this is how the backend of polygon works. Now, next, again, we have multi-polygons, which, define a collection of polygons. So these are some references. So this contains the outer box. And once I print it, you'll understand what these are about. Right. So the outer box is mentioned here, the references. And then the second line contains the inner box. Now, how is this relative to us or useful to us when we are dealing with geospatial data is, consider, a polygon meaning lots of lines converged of India. So we have the India polygon, and then in this polygon, I want polygon of Karnataka or New Delhi. So I can use these polygons and filter it from them, and that contains your outer polygon, which is your India, and the inside polygon is your Karnataka. So there are some data sets that are inbuiltly available in Geopandas, which we can use, which we can play around with and try to get hands on how Geopandas works. So that can be done by seeing datasets dot available. We'll explore this one by one so you understand what these are and how they work on the backend. Let's just read the file. So get path gives the path in which the library is present. And let's copy natural earth low-res, which we previously used. And now if I just plot it, now let's not use any resolution. So this is the entire world map, so which is present in natural earth low-res. Now, similarly, there is natural earth cities. And if we do df.plot, so now this, now maybe if I just zoom out, you can see it kind of resembles the world map, not exactly, but kind of resembles it. So this data set contains all the major cities that are present in the world. So if we just plot look at DFA. So these are single points, which we discussed a point on the map. And there are city names, Luxembourg, London, Singapore, Hong Kong, each having a point on the map. And finally, we have one final data set, which is NYBB, which actually is for New York cities. We have NYBB. So this is the map for New York City. All right. So these are the available data sets here. Now, if we go back to our Pandas EDA, just a second, guys. Let me just open that. Data EDA. Now, are we able to see the screen? Yes, you can. Okay, cool. Okay, so now if we deep dive into code, now you'll understand what's happening in the backend. So we took the Geopandas data, which is the natural Earth loess, and then we took the continent North America. So this is what it looks like. Now, in the GDF plot, we plotted the tree count. Now here is where it looks like, just a second. Yes. So this is what I wanted to explain is CRS. So again, coordinate reference system, which is accepted standard. Now there are multiple coordinate references system, which will be, there are a lot of CRS which you can look up. And so as I told, this is the accepted one, but there are others which have, clipped Antarctica and Arctic, and there's a actual relative distance map and everything, which my teammate Parikshit will be talking in the next session, which deep dives into what basically deep diving into a lot of visualizations on GeoPandas data frame. He'll be looking at chlorophyll maps and stuff. So make sure you register to that as well. It's a pretty interesting session. Okay, I think I'll just pause here just so you have any questions or anything. Any questions? Any? All right. Okay, no problem. Any doubts, questions? No. Okay, so that was a quick overview of how we have GeoPandas, which the go-to library for us, and then a couple of satellite formats that are present. And I think the information that you got from this presentation should be enough for you to just get started with geospatial data science. And also, so once you dive into it, you can understand, okay, the nuances, so that it's not so new to you and stuff. All right, so I have kept this session really short and lightweighted, so not as to deep dive. There are a lot of other things that we can do with GeoPandas data frame. There is spatial join, meaning you want a couple of locations that you have on a separate data set, and you want all those locations from another data set. Now it works similarly to Pandas merge, but Pandas merge is more on your numbers, but SJoin is more on a spatial level. So that's it. Thank you so much, guys. I will be sharing a couple of, I think the team actually will be sharing the resources that I used here, and also a GitHub link where all your resources are the notebooks that we presented here will be available to you. And yeah, that's it.
Thank you so much, Nithin. Yeah, before we proceed to answer your question, I would like to request the attendees to please fill the form of the feedback, as it helps us to conduct more such sessions.
Yeah, please let us know if you want more sessions on geospatial data science, and if you want to deep dive into QGIS tool, or if I think the visualization would be taken care by my teammate Parikshit. So make sure you register to that as well. And yeah, let us know how we can be of help.
I hope you guys have filled the feedback form. If not, I request you to please do it. And if you wish to conduct a webinar or facing any difficulty in registering, contact us with the email provided in the chat section. The recording of these session will be available within 2 days on our YouTube channel. And we will be back with another session of the data at 3 p.m. today. The link is in the chat section. Till then, have a good time. Keep learning.
Yes. Okay. I think we have a couple of questions that are left unanswered. I think one is from Sarang, which says, from which satellite do we get this data and how did we extract that into a CSV? Right. So majorly, a lot of satellite data that has HDF files, and CDF is basically from NASA. You can find that in earthdata.nasa.com. A lot of parameters. So there's weather, there is cloud cover, there is water vapor, there's soil, and a lot many things that you can play around with. So if you want to get started, I think there's probably a registration page on NASA which you can log into, and then you'll have free access to the data sets. Okay, what projects can we build during learning geospatial data? Okay, I think if you're just getting started with data science, Uber dataset is a really good way to start. So you can take the lat long. There's an entire data set that has all your orders that are placed and the locations from where a request was made and request was served, request was not served also. So I think that is a pretty useful data set that you can get started with. So, a lot of EDA you can do, say, in the weekends where you can visualize a heat map on where a lot of requests were made, where the requests failed, where were there a lot of requests, but we couldn't serve them because the cars were not available. So all these sorts of EDA. Okay, a full roadmap for geospatial data science. I think that starts with first understanding the domain knowledge. I think that's really important. So if you want, like, from starting base A to Z kind of thing, starting from zero, I think you would first need to start with the latitudes and longitudes. How is actually the earth made up of? What are the coordinate reference system? How can we identify location? All of this, which has actually been discussed in this seminar. Once you have that basics of domain knowledge built into you, then you can move on into more advanced things like playing with data frames. Now, the data that we handled here in this session is pretty lightweight. It's not even an MB or 2 MB. But when you start deep diving into big data sets, like say weather data for the entire world, it spans lots of TBs. So that's a lot of data. And I think the tool that's being used will come into play, and where you can deep dive into the tool, say Geopandas. Now, Geopandas again is not very user friendly for handling very large data sets. There are separate data sets available like Xarray, which you can work on raw satellite data formats. I think those will be helpful in a production environment, but your normal business related EDAs, everything Geopandas takes care of. All right. Yes, I'll be sharing my code on the GitHub. I think it'll be available in the resource section, along with the presentation and the datasets and the GitHub link. Also, one quick not shout out actually, but information. So since we understand Ambi and my teammates and I, since we understand the importance of geospatial data, what we are doing is we are creating an open source library which can help you. So you saw how we plotted, right? And in the next session that my teammate takes, you'll be looking at even more plotting, and it kind of becomes difficult. It's not straightforward like gdf.plot. It doesn't become like that when you are trying to make a lot of changes, or visualize it in a more deeper way. That's why we are building a library, which again will be shared in the resource section, and you can start it. And we are planning, there's a huge roadmap built around open sourcing things, and especially with respect to geospatial data science. So start that GitHub, and we can build a community together. Okay, Rajesh, I am presuming you're asking how to learn QGIS. I can actually just give a very small intro on how it works. I won't deep dive much, but let me just see if the QGIS is present. Okay. So just letting you know how this data set or this map came into picture is, so we need to create a layer first. Okay, I'll keep it very light here. So we did an ED on the Poland data, right? So that's the same CSV sheet that's linked here. If we go to the source, it's the Poland data, which the CSV sheet that we read. And we have created a symbology or classes. So these are the risk levels of the Poland data set. We have mapped that to this. And this is an OpenStreetMap that's freely available on QGIS, which you can use. So we pull in that layer, we add the Poland layer on top of it, we add classes, and that's how we are able to get this. Now, this is just a visualization, right? Now I can actually look at the data present there. If I click on I and a single point, you can see the data that's present here. So the postal code is 66846 and the tree count is 1260. Yeah, that's pretty very, very basic of how QGIS is. Okay, any source for learning QGIS? Yes. So there's the QGIS website itself, which is a beautiful documentation itself, which gives you an overview of how QGIS tool works. But apart from that, there are a lot of YouTube videos, data science channels that speak about QGIS. But what we noticed is geospatial data science is not as popular as your traditional data science. It's a separate subset which has huge potential of applications, especially with the climate change awareness that we are going into. But apart from that, there's not much sound on that, which is what we are trying to change at Ambi as well, trying to open source things and develop tools that will enable enthusiasts like you to get started with geospatial data science and just dive right into it without any sort of resistance and complex stuff. Now, I am not sure what you mean. What if I use Google Earth Engine for extracting data? Now, what sort of data are you trying to extract? Now, that depends. And modeling in Python is straightforward. I think probably if you want data that you can map to, satellite data, yes. So if you want satellite data, now there are two differences again there. There's difference between satellite data and there's a difference between satellite imagery. Now, satellite imagery is completely deep learning side of things, convolutional neural networks, but this data is more Python oriented. So yeah, if you can get your hands on data sets from NASA, and then you can try to model. So I think there are also a couple of data sets. There's one from Ambi. You can pull in weather APIs, Poland APIs, and model on top of that. So that's something you can do. Are there any live data connectors for critical applications? Nothing open sourced yet, but I think we can build one separately. Say, I'll just give an example of how things happen at Ambi. So, air quality and weather is critical, especially severe weather alerts. So we have a separate endpoint, API endpoint, which feeds in severe weather alert data. Now that can be consumed on our end to develop applications or, give alerts to users. Okay, I hope I have answered everybody's question. Anything else? Okay, I think that's it for this session, I guess. Thank you so much, guys, for tuning in. And I hope this session was informative. Please let us know in the feedback. It really helps us to get better. And yeah, have a great rest of Sunday. Actually, really happy that to see you guys have tuned in on a Sunday for learning data science. That really shows how much enthusiastic you are with respect to all these technologies. Yeah, awesome community.